Now, we previously noted that the function f of x equals 2 to the x is 1 to 1, and therefore it has an inverse. We saw that when we first looked at exponential functions. So let's figure out some values for the inverse function. The chart I have above is our chart for 2 to the x that we previously made. And so let's make a chart for the inverse of f of x. That means I need to switch my x and y values. So my y values are going to become -3, -2, -1, 0, 1, and 2. And my corresponding x values are going to become 1/8, 1/4, 1/2, 1, 2, and 4. So remember that XY pairing is reversing there, okay? Now, when we made this chart for 2 to the x previously, we then were able to graph 2 to the x. We're going to do the same thing now by graphing the inverse of 2 to the x. And guess what? The inverse of 2 to the x is log base 2 of x. So we are going to graph log base 2 of x. Now, currently on the graph is f of x equals 2 to the x. And we're going to graph log base 2 of x on this same set of axes. All right, so if we look at some of the points that we just came up with, we had 1/8 -3. We had 1/4 -2. We had 1/2 -1. We had 1, 0. We had 2, 1. And we had 4, 2. So we've got a graph that looks like the following. Now, remember we discussed this before, but because these two graphs are inverses, remember that they are also going to be symmetric around that line y equals x, which you can see in this picture is true. Okay. Let's talk about some things we're noticing about this graph of log base 2 of x. This particular one does not have a horizontal asymptote like 2 to the x did, but it has a vertical asymptote. Its vertical asymptote is that line x equals 0. It has an x-intercept of 1, 0. It has no y-intercept. And log base 2 of x is increasing. Anything else you see on this graph? No? Okay. We were able to graph this one by hand because we had made a chart. But if you need to graph this in your calculator, you're going to go to y equals, and you're going to have to type in log x over log 2. You're going to have to use that change of base formula. So let's see what that looks like in our next example. We want to graph log base 3 of x. So in order for me to do this, I need to enter this into my calculator as y equals log x over log 3. Okay, now I'm going to attempt, I'm going to see what happens, to switch over to a calculator and see what we come up with. Let's see if it will do that for us. Sure, we'll discard for a minute. I just got downloaded the other day that TI-84 emulator, which is awesome. So let's see what we can come up with here. Just thinking. Let's go this view. It looks prettier. All right, let's maximize that. So in my calculator, I am going to go to y equals. I'm going to clear out what I had from before. Okay, and I'm going to type in log x, close that parenthesis, divided by log 3. Close that parenthesis, and I'm going to hit graph. Okay, now notice on your calculator that once we get to right around here, our graph kind of ends in our calculator. You need to use that brain of yours to know that that really keeps going down and that this has a vertical asymptote at x equals 0. I know you guys don't always believe me, but you're smarter than your calculators. Okay, so you got to kind of put in those couple missing pieces there. Now, the PowerPoint slide asked me to give the domain and range of this function. Now, my domain, left to right, my x values would be from 0 to infinity. Notice that 0 gets a parenthesis because I've got a vertical asymptote there. Now, my range, bottom to top, y values, the lowest this graph goes is negative infinity. The highest it goes is going to be all the way to positive infinity. Okay. It also asks me to write the equation of the asymptote. We've already put that in there. It's x equals 0. We might want to make note of a couple other things. This graph is increasing. It does not have a y-intercept, but it does have an x-intercept of 1, 0. Okay. So you're hopefully starting to maybe see a couple similarities between these first two graphs. They've got that vertical asymptote. They're increasing. They go through that x-axis at 1, 0. Those are going to essentially be those common features that we have amongst these logarithmic graphs. All right, let me clear that out. There we go. Okay, the next slide asks me to graph log base 3 of x plus 1. Now, let me ask you this. X plus 1, it's in parentheses. If I think about how this is going to move my graph of log base 3 of x, which we just saw, what's going to happen? Because that plus 1 is in parentheses with that x, it is going to move my entire graph to the left one. Now, in terms of putting this into my calculator, I'm going to put log of x plus 1, close those parentheses, divided by log of 3. And we're going to hit graph. Now, again, we're smart. We know what's going on here. We know that this continues down. We also know that because I move this to the left 1, that vertical asymptote that was at 0 is now at -1. That x-intercept that I had that was at 1, 0, because I moved it to the left 1, it's actually now at 0, 0. So this whole graph shifted to the left 1, okay? That means my domain also changed. My domain is now -1 to infinity. But my range has not changed. Range bottom to top, those y values is still -infinity to infinity, and that graph is still increasing. Okay, let's see what happens now if we switch this to log base 1/3 of x. What do you think's going to happen? Make a hypothesis, make a guess. All right, I'm clearing this out. Maybe, maybe not. There we go. Okay, I'm going to go to y equals. I'm going to clear this out. This time we're going to put in log x divided by log of 1/3. So I'm going to do that as 1 divided by 3. Okay, and we are going to hit graph. Let's see if your hypotheses were accurate. So, did you decide that it was going to make it decrease instead? That's what's going on here. This graph still continues up. Realize that your calculator doesn't show that continuation, but you got to be smarter than it. And we still have a vertical asymptote at x equals 0. I still have that x-intercept at 1, 0. But the big difference here is instead of increasing, it is now decreasing. So log base 1/3 of x, this base of 1/3 made it decrease. And let's see, my domain is still what, 0 to infinity. My range would still be -infinity to infinity. So, are you seeing the connection here too with exponential functions? Remember with exponential functions, a to the x, when a was greater than 0, or when a was greater than 1, it was increasing. When a was less than 1, it was decreasing. Same's going to be true for logarithmic graphs. When I had log base 3 of x, my graph was increasing. But log base 1/3 of x, now my graph's going to be decreasing. So that base plays a part in whether it's increasing or decreasing there. So let me switch back to my PowerPoint. Bear with me. And we are going to compare and make a nice, concise table of the properties of logarithms versus exponential functions. So, with my logarithms, I find that when I have a generic logarithmic graph, my domain is going to be 0 to infinity. And that my range is going to be -infinity to infinity. Now, remember that logarithmic and exponential functions are inverses of one another. So that means their domain and range, or their x's and y's, are going to be flip-flopped from one another. So the domain of an exponential function is -infinity to infinity, but its range is 0 to infinity. All right, my intercept on my logarithmic graph is an x-intercept, and it's the point 1, 0. My intercept on an exponential function is a y-intercept, and it's the point 0, 1. My asymptote on a logarithmic function is a vertical asymptote, and it takes the form x equals 0. But on my exponential function, it's a horizontal asymptote, which is y equals 0. Both logarithmic and exponential functions, if a is greater than 1, I find that it's increasing. If it's less than 1, I find that it's decreasing. So this is a nice, concise chart here of some of the similarities and differences between logarithm and exponential functions. All right, let's try one more graphing example, and then we just have some application problems. All right, we want to choose the graph of y equals log base 1/16 of x plus 2. So, right off the bat, because my base is 1/16, I know that my graph needs to be decreasing. This plus 2, which is not in parentheses, it's after the fact, plus 2, means that I'm going to move my whole graph up 2. Okay, so let's think about what's happening here. I'm going to have a decreasing graph. So I know right off the bat it's not the upper left or the bottom left. And then I need to move my whole graph up 2. Well, that top right one moved it to the right 2. Up 2 is going to come from that bottom right. All right, in the next set of, or the last section of our video for Notes W, I'm going to do some logarithmic application examples. There we go. So I'm going to end this video here, and then we'll pick up with those applications in the next one.